The Crookes tube that was used to study cathode rays, which then resulted in the discovery of the electron, was also instrumental in discovering X-rays. William Röntgen was experimenting with various configurations of the Crookes tube in order to study more properties of the cathode rays. He then shielded the tube with black cardboard. He did this so no light or cathode rays would emerge. He energized the tube, turned off the lights, and wanted to see how good his shield was. He then noticed, several meters away, a screen coated with barium platinocyanide was glowing. He had planned on using the screen later in the experiment, but he certainly didn't expect anything to happen while he had the Crookes tube shielded. Röntgen knew that the glow on that other panel could not be caused by the cathode rays, because the cathode rays should be and were stopped by the cardboard, and his shielding was perfect. So he theorized that some other kind of ray was passing through the shielding and causing that screen to glow, just like the electrons cause the phosphors to glow on the inside of the Crookes tube. Because it was unknown, he came up with the term X-rays. Physicists are never very good at coming up with terribly clever names. Very rapidly, he tested other objects to determine the penetration power of these X-rays. What could they go through? What could stop them? And this is just another great example in science where a discovery was made quite by accident. You can search on the web for other discoveries made like this. Two things come to mind: vulcanized rubber, and also the Big Bang Theory, the origin of the universe. At this time, the dangers of excessive exposure to X-rays were not known, and many demonstrations occurred which just wouldn't happen today. 2 weeks after their discovery, Röntgen took an X-ray photograph of the hand of his wife, Anna Bertha Ludwig. He placed a photographic plate behind her hand, and he directed the X-rays at her hand. The plate would show light where the X-rays touched it. So this is the plate, so you can see the light here. That's where X-rays are going through and exposing the photographic plate. If the X-rays didn't strike the plate, it would be dark. So take a couple seconds and think about it. Explain why the picture of Anna's hand looks like it does. A couple of slides ago we talked how Röntgen would expose different materials to the X-rays and try and measure the penetrating power. So one of the things you find out, and it's very obvious in this picture, is dense objects, very dense objects, such as Anna's finger bones, shown here, and her very prominent wedding band, right over here. Here's her wedding ring, probably made out of gold or something. These would stop the X-rays, and you would get a shadow on the photographic plate. Less dense objects, such as skin, right, because we're presuming she has skin over here, all over her bones there, would allow the X-rays to pass mostly unhindered, and the plate would be lit up. Another question: why would the medical profession immediately be interested in this discovery? Physicians could now see bone damage. If somebody came in and you suspected a broken bone, prior to this discovery you would have to kind of feel around the skin outside. Perhaps you'd actually have to cut the person open. Now you don't have to. You could find out where the bone is, where it's broken, and treat it properly. And if it was a bullet wound, and this would certainly come in time of war or other bad things, you could actually see the bullet inside the body too and know how to get it out. There is a problem though. X-rays have a great deal of energy, far more energy than, for example, the electrons, than photons, and they can knock out electrons from atoms, which ionizes them. That's not good. Molecular bonds can be disrupted. So if you're X-raying a box to see what's inside of it, no problem. However, if you're X-raying a person, you have to be very careful, because if you expose too much of the person to X-ray radiation, you will damage tissue. You could cause radiation sickness. That's why, for example, when you go to the dentist and you get X-rays of your teeth, the doctor is very careful to shield your body with a lead drape. They want the X-rays only to go in a specific directed area of your teeth. It's very carefully monitored and controlled so the side effects are minimized, and the benefits of using it way outweigh any hazards as long as they keep it at low levels. Further experimentation showed that the intensity of the X-rays increased with denser target plates, which were the anodes. If you'll recall from the cathode ray tubes, the material of the cathode and the anode did not affect the intensity of the electrons. However, for the X-rays they did. It was also discovered that these rays were not affected by electric or magnetic fields. They were not deflected, as was in the case when electron experiments were done. So, what does it say about the charge on the X-rays? Well, if the path of the X-rays are not affected by magnetic or electric fields, then there must not be a charge on them. Hence, they are neutral. They are neither positive nor negative. They are neutrally charged. Later research showed that X-rays were not particles, but another kind of electromagnetic radiation.